Let's look at number 7. In this one, we're finding all the exact solutions first, and then all the exact solutions between 0 and 360. That means we're looking for solutions in degrees. And this one, it's already factored for us. So what we're going to do is take each one of these factors and set it equal to 0. And since our angle in here is theta over 2, we're first going to solve for theta over 2, and then we're going to take that and solve for theta. We can start out with the cosecant of theta over 2 equals 0. That's one equation we're going to solve. And then cosecant squared of theta over 2 minus 1 equals 0. That's our second equation to solve. Now for this one, since we have this equal to 0, if you think about it, cosecant is the reciprocal of sine. For cosecant to be equal to 0, that would mean that sine would have to be undefined, which doesn't ever happen. So this one really has no solution. This one we can try to solve. For this one, we want to solve for the cosecant squared first. We can do that by adding 1 to each side. And then we want to figure out where. Next, we want to take the square root of each side so that we're just down to cosecant. If we take the square root on this side, we have to do plus or minus. The square root of 1 is 1. So we end up with cosecant of theta over 2 equals plus or minus 1. Cosecant is the reciprocal of sine. So for cosecant to be plus or minus 1, that means sine would have to be plus or minus 1. We could simplify this a little bit and think of this as sine instead of cosecant. This is the one place where sine and cosecant have the same value, is at when it's either plus or minus 1. If we're thinking about where sine is plus or minus 1, for theta over 2, this is going to happen at either 90 degrees or 270 degrees. Those are the only two places. At 90 degrees, it's positive 1. At 270, it's negative 1. Now we want to write this with all the solutions, putting in the coterminal angles. This would be 90 degrees plus 360 degrees n, and 270 degrees plus 360 degrees n. Now what we're going to do to solve for theta is multiply everything by 2. That's going to give us 180 degrees here, and it's going to turn this into 720 degrees n. 270 times 2 is 540 degrees. We'd have that plus 720 degrees n. So this is all of our exact solutions for theta. Now, if we want to find all the exact solutions just between 0 and 360, again, since we had 2 solutions here, we can think of it that we're going to have half as many when we solve for theta in between 0 and 360 degrees. If we look at these two, if we're just looking for things that are between 0 and 360, we'd have the 180. If we add 720 degrees to that, we won't get something that's less than 360. So that would be all we'd get from that one. And for this one, this is already over 360 degrees. So this is the only solution that we get between 0 and 360. Now let's do 7b. In this one, since we have things on both sides, again, we don't want to cancel out the cosine of 2 theta, even though we have it on both sides. Canceling it out is going to cancel out some of our solutions. So instead of doing that, let's add this whole term to both sides so that we have a 0 on this side. That gives us plus 2 sine 2 theta cosine 2 theta. And then that gives us a 0 on this side. Now we can factor out that cosine of 2 theta. What we have left from here is the square root of 3. From here we have 2 sine 2 theta. Now we can take each one of our factors and set it equal to 0. Let's start with this one, and we're solving for the 2 theta first, where cosine is equal to 0 in degrees is at 90 degrees and at 270 degrees. If we solve this one, We want to solve it first for the sine of 2 theta. That means subtracting the square root of 3 from each side, and then dividing by 2. That gives us sine of 2 theta equals the negative square root of 3 over 2. There should be 2 places between 0 and 360 where this is true. Since this is negative, that would be in the 3rd quadrant and the 4th quadrant. So let's think about our reference angle first. That would be where sine of 2 theta is equal to positive square root of 3 over 2, and that would be at 60 degrees. This is not going to be one of our solutions. We want angles in the 3rd quadrant. For the 3rd quadrant, we're going to take 180 plus 60 degrees. That gives us 240 degrees. And for the 4th quadrant, we take 360 degrees minus 60 degrees, and that gives us 300 degrees. So these are our 2 solutions. This one wasn't a solution, it just helped us find it. So for 2 theta, now we have 4 different answers. We're going to take these and write them with all the coterminal angles. That means we have 90 degrees plus 360n, then 240 plus 360n, 270 plus 360n, and 300 plus 360n. Those are our solutions for 2 theta. To solve for theta, we want to divide everything by 2. So this would be 45 degrees. Remember also to divide these by 2. That would make that 180n. This would be 120 degrees plus 180n. This would be 135 degrees plus 180n. And this would be 150 degrees plus 180n. Those are all of our solutions for theta. Now if we want to find all the solutions between 0 and 360, since we had 4 different solutions for 2 theta, that means between 0 and 360 we're going to have 2 times this many, so we should come out with 8 solutions between 0 and 360. What we're really looking for is 2 solutions from each one of these. So we could start with 45 degrees, then 45 plus 180 is 225. Then let's go on to 120. Then 120 plus 180 is 300. Then we've got 135, and 135 plus 180 is 315. Then we have 150, and 150 plus 180 is 330 degrees. So there are our 8 solutions.